everyone. Hope you have started thinking about three-dimensional geometry of your class 12 syllabus. Whatever you have done in the previous session, that you must have gone through. If you have not seen it yet, please go through the previous video, that is the introduction of three-dimensional geometry, where I have explained the concept of direction ratios and direction cosines and angle between two lines mainly. This session, at first I will be discussing the length of projection of a line segment or a vector on a line or a line segment or another vector. In vector dot product, already I have explained the concept of projection of vector A on vector B. The formula I hope you all remember, but that formula is applicable in three-dimensional geometry because we will be treating 3D geometry here with the help of vector. What is the meaning of the length of projection of one vector on another vector? At first, let me explain the length of, what is the meaning of projection? That projection of a point is possible on a line. This is the line or line segment or a vector. We want to find projection of a point A on this line. It may be a line, segment, part of line, or a vector. How do we get length of projection? From here, if you draw a perpendicular, that foot of perpendicular M is the projection of, M stands for projection of the point A on the line or segment, line segment. Then the length of projection of a line segment or a vector on another line segment or a vector or on a line. This is the vector, AB is the vector. We want to find the length of projection of this vector on it. Already in dot product, you must have seen that the length of projection we found, that is maybe episode 2 or 3 in vector. Please go through it. There I told you if this angle is theta and this is the vector A and this one is vector B, then length of projection is actually distance between these 2 points. So LM stands for projection of AB or vector A. We cannot define it for vector only, we can define it for any line segment. This is projection of AB on vector B or the line segment or line is what? That is LM. LM is what? In this diagram, LM stands for AR. Okay? Because LM equal to AR, because you have dropped perpendicular here and this also perpendicular dropped on BM. So AR going to be equal to LM. So LM equal to AR, that is equal to, in this diagram you can see that AR by AB equal to cos theta, therefore AR equal to AB cos theta. this is nothing but mod A cos theta. Okay. So AR equal to mod A cos theta, which we can rewrite as A dot B by mod B. This is just, I remind you, what you have done in dot product, that is A dot B. B cap. B cap is what? That is unit vector along the vector B. Okay. So length of projection of vector A on vector B or the line whose part is this directed line segment or only line segment is given by A dot B cap. See, when we have learned 3-dimensional geometry, no vector was there. I mean, vector was there, but as a different subject. You are applying the concept of vector to get better idea of 3-dimensional geometry. And length of projection of vector AB, that is A on B, we found A dot B cap. Now, we want to find the length of projection, say, of line segment whose two extremities are given. We don't know whether it will be a vector or not, but this extremity is given x1, y1, z1 and this one x2, y2, z2. Your problem is to find the length of projection on this line segment whose direction cosines are known. Now, what I told you, purely 3D geometry, no vector was there. So, there is vector AB, no, there is line segment AB and there is a line here. I did not specify anything vector over there. Your problem is to find length of projection of this line segment whose two extremities are there on this line whose direction cosines are LMN. How to find it? From the end point, the same way we will do. That first we will think that there is a line segment. Once you draw these perpendiculars, put these perpendiculars you have to draw, the concept remains the same. AL and BM, these are the two perpendiculars drawn on the line from A and B. Now, this part, as told earlier, that LM is the length of projection. Okay. This definition valid for all cases in vector and 3D wherever you apply. Projected part of AB on the line segment or line is LM. LM is what? Again the same thing, that is the way we are doing AR. But here it is not given vector. Lines, direction cosines given. So we solve the problem this manner. We think that instead of line segment AB, there is a vector AB. Instead of line, we consider there is a vector in this direction. Length of projection, if you imagine that there is vector B over there and this is our vector A, then LM is A dot B cap. We have found it already. Isn't it? So, here also the projection, length of projection of this line segment is nothing but length of projection of vector AB on the line. Okay? And what is the unit vector along LM? The way I told you earlier that L is cos alpha, this line segment makes say alpha, beta, gamma with the coordinate axis. This one cos beta and N is cos gamma. So what about L square plus M square plus N square? This is nothing but 1. Okay. So if we want to find length of projection now, length of AB, AB is a line segment. AB is a line segment or AB vector. Projection of vector AB. Length of projection of AB or projection of vector AB. We are just simplifying it. AB line segment, along that direction a vector can be defined. So length of projection concept will remain the same, that is LM only. Length of projection of AB on the line, this is the line or part of line, on the line is what? Same, that is AB dot LM cap unit vector. Now what is the unit vector in the direction of the line? That is given by LM cap. LM cap we want to write. Along this direction, the direction cosines are given. We can write LM as Li plus Mj plus Nk. These are direction cosines, length is 1. So actually that unit vector we have written here, LM cap we can write Li, Mj, Nk. Why? Because LM cap is going to be mod of Li plus Mj plus Nk. So this is nothing but root over L square plus M square plus N square. And direction is specified by the direction cosines. So if we say that LM cap is this is justified. But now AB was not a vector, it was a line segment. But I told you we can make it a vector over there. AB vector is what? It is position vector of B minus position vector of A dot LM cap. What is that? B is x to I, y to j, z to k minus x1i, y1j, z1k. We have written this thing here, no? This dot product with LM. LM cap. LM cap we have found here. That is Li, Mj, Nk. We'll just put their values over there. Okay? So this you simplify first. x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap, and dot product with Li, Mj, Nk, which is nothing but dot product with this L into x2 minus x1, M y2 minus y1, N z2 minus z1. So we are able to derive a formula which is length of projection of a line segment on a vector, on a line or a line segment by this formula in scalar form. No vector is there. In 3D, we can use both the concepts, this A dot B cap as well as this thing, because here it is more specified, because you know the extreme points x1, z1, x2, y2, z2, and you are finding it on a line whose direction cosines are L, M and N respectively. The formula is this. So for example, if I tell you one thing, suppose there is I am taking one example here for your convenience. Let A be this point 3, 1, 2, B is this point minus 4, 3, 5. Find the length of projection of AB on CD, where C is this point, say -3, -2, -4, and D is 7, 8, 3. Okay? So how do you solve the problem here? Start thinking. AB is given. AB you take this manner. You always take a diagram there. In theory you have to imagine. If you cannot draw, imagine that AB is there. A is what? 3, 1, 2. B is what? -4, 3, 5. And you want to find length of projection on CD. On this, what you will do here? You draw a perpendicular here, or you don't draw a perpendicular. You got the formula here. I am just showing you. This is the length of projection, and the formula is x2 minus x1 L plus y2 minus y1 M plus z2 minus z1 N. Isn't it? Because AB vector we can find now using this thing. Length of projection, this is the formula for length of projection, that is LM. This is length of projection. But what is x2 minus x1 here? That AB, if you write the vector again, it is minus 7i, position vector of B minus A, minus 7i, 2j, 3k. And element direction cosines of CD. How to find it? That you write first drs of CD. Those are what? 7 minus minus 3, 10, and 10 and 7. Direction ratios of CD are known. And I told you how to find the dishes of CD. Direction ratios, once you find, you get dishes also. Dishes of CD are what? That is 10 by under root 10 square, 10 square. You remember the formula? These are ABC only. A by sigma square. That is under root 100 plus. All these I have explained in the previous video. So direction cosines, it is going to be like this. Then again 10 by this 100, 149, same thing. And this is 7 by under root 249. So this what you got. This is basically x2 minus x1 I cap, y2 minus y1 j cap. You need not write I cap j cap. Direct formula plus z2 minus z1 k cap. You need only this part, and this part. So x2 minus x1 is minus 7 into 10 by root 249 plus y2 minus y1. y2 minus y1 is 2 into 10 by root 49 plus 3 into 7 by, so this will be mod. The length of projection modular sign always will be there. Please don't forget, because length is never negative in the sense of mathematics or all subjects. That you think. But in mathematics, length will always represent by this. That is 41. So there will be minus 29 by root 249 mod. So answer is 29 by 249 unit. This is the length of projection. So formula you have learned, and you got one sum also over there where you can find the length of projection easily once you find the direction cosine of the line. Okay. So let us solve this problem using concept of direction ratios. Prove that the points A, B, C and D taken in order are the vertices of a rectangle. This we are going to prove. These are the points given. You have to prove that these points are the vertices of a rectangle. How do we apply the concept of direction ratio? Here, AB given, just the concept of direction ratio. I have told you, if two lines have direction ratios A1, B1, C1 and A2, B2, C2, then the angle between two lines can be written by using the formula that L1, L2 plus M1, M2 plus N1, N2 or A1, A2 B1, B2 by under root sigma A1 square under root sigma A2 square. And lines are perpendicular if the cosine of the angle between them is equal to 0. If lines are perpendicular, then L1, L2 plus M1, M2 plus N1, N2 0, or you can state that A1, A2 plus B1, B2 plus C1, C2 0. So how to proceed here in this sum? 4 points given. You just write the direction ratios of AB, AD and DC. That is enough. Okay? You write all direction ratios of AB. 5 minus 4, 1, minus 3, minus 2, minus 5 and 7. And for this one direction ratios are what? 7, 12 minus 5, 7 and then 4. For DC what? That is 1 CD, no? Or DC, whatever you say. DC I am taking. So 12 minus 11, 1 and minus 5 and 7. And what about AD? D minus A, that is again 7, 9 minus 2 is 7 and the other one is minus 2 plus 6, that is 4. Okay? So you can see that initially AB and DC, they have the same direction ratios. So AB is parallel to DC and BC is parallel to AD. So you will write this manner. Obviously that it is clear that ABCD is a parallelogram because opposite sides are parallel. Two lines AB and BC having the same direction ratio, ADBC also have the same direction ratio, so it must be a parallelogram. Now you just need to prove that one of the angle 90 degree. It will ensure that all remaining angles each equal to 90 degree. So let us find AB and AD, AB and AD. In that case, A1, A2, B1, B2, C1, C2 sum. That I have told you, if A1, A2, B1, B2, C1, C2 0, then lines will be perpendicular. So this time, AB and AD, they are, in that case, if we assume that this is A1, A2, A3, and this one B1, B2, B3, then we will simply find A1, A2 plus B1, B2 plus or A1, B1 I have taken. Sorry, you take A1, B1. A1, B1 taking in pair, A1, B1 plus, don't be confused with the symbol, A3, B3. You need this product. One from here, one from the other. is 7 into 1 plus 7 into minus 5 plus 4 into 7. 7 minus minus 28 plus 20 is 0. So it will ensure that this angle AD is perpendicular to AB. Hence, ABCD is a parallelogram. Alright? Sorry, it's a rectangle because one angle 90 degree and already we have proved that it's a parallelogram. Now I am going to discuss one kind of sum where you will be confused in the beginning because two lines are involved that you have to understand from there. Let me write the sum here first.